Laser beam divergence and spot size. Laser light, usually a spatially coherent, narrow low divergence beam that can be manipulated with lenses. In this experiment, our aim is to find the laser beam divergence and spot size using a detector. The light emitted by a laser is confined to a rather narrow cone, but as the beam propagates outward, it slowly diverges or fans out. At the output aperture of the laser, the beam diameter is d. Its beam divergence angle theta, usually expressed in milliradians. In traversing a distance L, the beam diverges to a circle of diameter d'. That is, the beam divergence is an angular measure of increase in beam diameter with distance from the optical aperture from which the electromagnetic beam emerges. The spot size of the beam is the radial distance from the center of maximum irradiance or intensity to the 1 by e square points. Procedures. Number 1. Set a laser and a detector for measuring the intensity on an optical breadboard. Number 2. Align the laser beam in such a way that the laser beam can fall on the detector. Number 3. Fix a distance for the detector and take intensity measurements of the beam along a horizontal line, passing through the point with the maximum intensity. Number 4. Repeat the previous step for different variants. Number 5. Calculate the beam divergence by calculating the maximum intensity of the beam, which helps in calculating the beam spot size at different distances from the laser with the help of the optical breadboard. Now we can observe that the divergence of a laser beam is proportional to its wavelength and inversely proportional to the diameter of the beam at its narrowest point.